Hello friends! I hope you all had a wonderful weekend. Miss Kat is here with Pi to continue our exploration on the physics of light. Are you ready, Pi? Okay, beautiful. Before we begin our experiment today, we are going to play a quick review game about all of our glossary terms from the previous 3 weeks. So, Pi, what do me, you, the table, and the projector all have in common? Okay, I'll give you a hint. The hint is you can use any of the words from our glossary. Ooh, very good, Pi. We are all opaque. Pi, do you remember what the word opaque means? Ooh, very good. So opaque means that no light can pass through an object, and all of that light, where's that light going, Pi? Ooh, very good. Some of that light is being reflected back at the viewer. That's why you can see us right now. The light from our light source is hitting me, is hitting Pi, is hitting the projector, and bouncing back at the camera, back at home, so that you can see us. And if the light source changes direction, you'll notice that opaque objects block the light. So when the light source changes position, the shadow that we are creating changes position, because that is where the light cannot go through. All right, so now Pi, are you ready for round 2? Okay, now Pi, what do all the objects in front of us have in common? Did that surprise you, Pi? Oh my goodness, was that real magic or movie magic? We'll never know. All right, Pi, so to repeat the question, what do all of these objects have in common? Your hint is that you can use a word from our glossary from the past 3 weeks. Yes, Pi, very good. All of these objects are transparent. What does transparent mean, Pi? Ooh, very good, Pi. Transparent means that all of the light can pass through to the other side of the object. That's why they appear clear. So Pi, with that being said, do transparent objects reflect or refract light? So to answer this question, you should be thinking, what does reflection mean? What does refraction mean? Oh, very good, Pi. So all of these objects refract light. Pi, what is a synonym for refract? Very good. A synonym for refract is to bend. So instead of going in a straight line, when the light hits the boundary between two transparent medium, it stops going straight and it bends and then starts going in another direction. Pi, since we're talking about synonyms, what is a synonym for the word reflect? A synonym for the word reflect. I'll give you a hint. Very good. A synonym for the word reflect is to bounce. So do transparent objects reflect light, or do opaque objects reflect light? Very good, Pi. So we can think that opaque objects reflect light, transparent objects refract light. One of our goals this week is to master the difference between reflection and refraction. So, without further ado, Pi, what do you think our science question could be today if we are using all of these objects in our experiment? No, Pi, that's ridiculous. We do not have access to a puppy-sized elephant. I know, I'm very sorry. Let's see, what do you notice about the shapes of all of these different containers? Are they the same or are they different? Ooh, yes, they're all very different. Let's take a look at that right now. So we see that this jar over here is more narrow. We have a wide jar. We have a small, short bowl. We have a large bowl. This actually has 9 sides. So the bottom of this glass is a Nonagon Prism. That is a fancy word for a prism that has 9 sides. And then we also have this rectangular prism, because Miss Cat is really curious how light will travel, not just through curved shapes, but also flat shapes. So, do you think you know what our science question is today? Oh, good job. You hit the nail on the head, Pi. Our science question is today, how will light travel through transparent objects of different shapes? So, before I send you off to make your question and your hypothesis in your science notebooks, we should look at light that's not traveling through any of these objects first so you can make super strong, precise hypotheses. I have my handy dandy headlamp to help us out with that. Pi, can you help me turn that on? Ooh, very good, Pi. So let's look at the shape of the light before any of these transparent objects are in front of it. What shape is that light, Pi? Ooh, very good. Do you see how it's just a circle? So for your hypothesis, you should be thinking, what is going to happen when we take the same light and we put each of these transparent objects in front of it? Will it still be a circle? Will it change shape? Will it change shape based on the position of these objects? When you make your hypothesis, remember you need to specifically tell me what you think is going to happen and why you think that is going to happen. You should be very specific in your hypothesis. Tell me, what do you think will specifically happen with a small bowl and why? What do you specifically think will happen with the nonagonal prism and why? If you are in 3rd grade, I want you to choose at least 3 specific objects that are in front of you to include in your hypothesis. If you are in 4th grade, I want you to choose at least 1, 2, 3, 4 objects in front of you to discuss in your hypothesis. If you are in 5th grade, I would like you to please talk about each object individually in your hypothesis and tell me why you think that. So without further ado, I will now up close show you the questions so you can take some time to write your question and your hypothesis. Okay, friends, so you can see that I turned to the next page in my science notebook. I wrote the date in the upper left-hand corner, wrote my heading in my neatest handwriting with a capitalized letter at the front. I underlined it with a colon, and I wrote our question: how will light travel through transparent objects of different shapes? After you write your question, you should skip 1 line, write the word hypothesis, spelled hypothesis, underline it with a colon, don't forget to capitalize that H, and then our hypothesis always starts with the words I predict. So you might want to say, I predict that when the light travels through, and then remember I told you I wanted you to refer to the specific objects that we will be testing in our science experiment. So they're right here to help you write your hypothesis. The only one you cannot see on screen is the rectangular prism at the bottom, which has a flat surface on the front, versus all the others that are more curved. This has 9 flat sides, this nonagonal prism. So again, if you are in 3rd grade, choose 3 of those items to specifically talk about. 4th grade, 4 of those items to specifically talk about. And 5th grade, please talk about each item individually in your hypothesis. I will now give you some time to finish your hypothesis. Don't forget the word because, and then unpause the video when you are ready to make your data chart. All right. So if you are unpausing the video at this point, that means you have finished writing your hypothesis with the word because, thoroughly explaining why you think that, using maybe examples from real life or making connections to previous experiments. Then I would like you to please use your straight edge to make a data table with 1, 2, 3 vertical lines and 1, 2, 3, 4, 5, 6, 7, 8 horizontal lines. I left 2 spaces at the top to write my headings object and luminous source observations. Then I went through and I drew pictures of each of my containers individually. You can either draw pictures of the containers just like I did, or if you want, you can just write the name of the container. So you could write nonagonal prism, you could write large bowl, small bowl, wide jar, narrow jar, or you can just draw the pictures. I left 3 spaces for each of these so that I can include plenty of information where I wrote observations. So at this point, you can pause the video, get your straight edge, and make this data table. After you have finished making your data table, we are actually going to make a second data chart because we are doing 2 fair tests. We are doing a fair test first with a luminous object, my headlamp, and then we are going to be doing the same fair test with a non-luminous object. My friend Lola will be the non-luminous object that I will be using for our second fair test. Your data table for your second fair test looks exactly the same as the first fair test, except instead of writing luminous source observations, you are writing not luminous source observations. It's the exact same table with the exact same jars. The only thing you change is this heading. So please take some time to complete that beautifully. You only have one experiment for 2 weeks, so please, please, please take your time. I would rather you have one beautiful experiment completed at the end of 2 weeks than a bunch of experiments that are not your very, very, very best work. So again, this is our first data table. And our second data table for our 2 fair tests. You can pause the video here, make sure you get that done, and then I will join you for the experiment. Okay, friends, so now you should have finished writing the question. You should have finished writing your hypothesis supported by detailed examples from your real life to explain why you think that. You should have made your first data chart for the first fair test and your second data chart for the second fair test. So you can get ready now with your first data chart for the first fair test and follow along with me, recording your observations in pictures, words, or both. So I want you to once again look at our luminous light source. Just on its own, I want you to notice what shape it is, and then we're going to see how that shape is affected when the light is now traveling through our transparent objects. So let's first test the narrow jar. And then if you're doing this at home as well, you might want to shine it dead on, but I'm shining it at an angle so that you can see it in the video. So I want you to notice what's happening to the shape of the light, what's happening to the intensity of the light. Maybe you want to pause the video right here and you want to create a beautiful detailed drawing of exactly what you see. Maybe you also want to describe in words how the light looks compared to the shape of the jar and start to think about why that's happening. So you can pause the video there if you need to, or go back a little bit if you need to, but I'm going to move on to the second jar. Now we are going to test the wide jar. Hold on. There you go, sorry about that. All right, now we're going to test the wide jar. I am going to shine my light source through it. And then how is the light different than when it was traveling through our first jar? How is it similar to when it was traveling through our first jar? Again, if you want to pause this right here and you're finding something particularly interesting and you want to jot down a drawing of that, you may. All right, now I'm going to move on to our third jar. Can you hear that? Hold on one second. All right, I have no idea why so many people are out on their balconies clapping right now, but anyway, they seem to have stopped. So I think we were looking at the small bowl, the large bowl, the small bowl. So now you're noticing, how does the light look different when it's passing through the small bowl versus just through normal air? You can record your observations in pictures, in words, or both. Please pause the video if you need to make sure that all of your data is super thorough. I'm going to move on to the fourth bowl, the large bowl. I'm going to hold it carefully at the bottom. Ooh, so how is the light similar but different to the light that was passing through the small bowl? I'm already noticing some very clear similarities, but some very clear differences, because we know that these bowls are basically the same shape, but one is twice as large as the other. And again, the water is moving, so you can also include those details of what is happening to the light because the water is moving and why. Please try to use science words like refract if you are describing your observations. Oh, that's neat. That's pretty. Okay, next let's look at our Nonagon Prism. I'm going to hold my jar at the bottom, my cup at the bottom, and shine my light through. I'm going to turn it, see what happens. Interesting. So I'm already noticing through this one, we're getting a little bit of shadow in certain places. So you should be thinking, why is that happening? Oh, that's neat. And then when I rotate it, what is happening? I don't want you to say too much because I want you to observe very carefully on your own. Tell me if you think the light is refracting or not, and why. Please pause the video if you need so you have detailed observations for 1, 2, 3, 4, 5 transparent containers. And now I'm going to try my last transparent container. Here is it normal. And boop. Normal. Oh, interesting. There's the light going through air and our flat transparent material. Air, flat transparent material. What did you think was going to happen? Was your hypothesis correct? Was your hypothesis a little bit correct? Why do you think this is happening? How is this container different and similar to the other containers, and how is that affecting the light that is passing through it? Is the light changing size slightly? Is it changing color slightly? You tell me. I can't wait to see your data tables and read everything that you noticed. Okay, friends. So please pause the video there if you need, and make sure that you have observations for 1, 2, 3, 4, 5, 6 containers in your first data chart. You should have left 3 lines, so you should definitely fill all of this space up because that is a solid amount of space, but not so much space that you can't fill it up, regardless of what grade we're in. Okay, and then once you are finished, you can now turn to your next data table. Instead of using a luminous light source, we are going to be using a non-luminous light source. My non-luminous light source is named Lola. This is Lola the lion. She is going to be joining us for this part of the experiment. She's so excited, right, Lola? That means, yes, I'm very excited in Lion Cub. Okay, friends, so now instead of having a luminous light source that emits light on its own, Lola is a non-luminous light source. She is still reflecting light back at her eyes, but she's not the main source of light. That makes her non-luminous as opposed to luminous. So let's look at how Lola looks through all of these containers. Here's Lola normal. And actually, I'm just going to start us out by having her walk past all of these containers so we can compare them all to each other, and you can start recording your observations. Does she look different in this container versus this container? Hey, Lola. Thank you, Lola. Do you mind that I did sound effects for you? No, she doesn't mind at all. Sound effects always make everything better. Okay, so we just saw that far away so that you could directly compare everything. Continue to record your observations in words and in drawings, and I'm going to show you all of that, but close up. So here is our first container, and here is our Lola. Oh, so actually this jar, notice that it's flat on this side, and then it's more curved on the 4 corners. So Lola actually is going to look different based on the curvature of the jar. Oh yes, because when she's going through the corners where there's a more dramatic curve, notice how Lola looks different. There she is normal, and there she is through that jar. So you could draw a picture of what Lola looks like through this jar, or you can use your words to describe her, or you can do both. Again, you have 2 entire weeks to do this experiment, so I would take the time and do both to make sure that you have a very beautiful and accurate representation about what you learned for these 2 weeks in science. Here is our second jar. So how is this one different to the first jar? Here she is normal. Can we get her half under, half over? Ooh! Oh, for a second I thought that her head was on the bottom, but it was just her legs doubling. Hey, Lola. This is fun. So friends, at home, you can get a picture of a book. You can also make a little lion or a little drawing or a little friend of anything at home, and just find any clear containers or translucent containers in your own home, and then observe the different objects behind those translucent containers, seeing how they're different based on the shape of that transparent or translucent container. But I happen to have a lot of transparent containers, so I'm just going to look at those, so it's a fair test. So this jar is uniformly curved, which is very different from the first jar that was not uniformly curved. So how is Lola different? Woo, look how big your feet look, Lola. So please record your observations, and you're also thinking, why is this happening? What's happening to the light that is traveling from our luminous light source to Lola, then back at you, our viewer? Let's now look at the fourth bowl, the large bowl. Ready, Lola, to go for another swim? Boop. How is Lola different in this bowl than the last bowl? You might even want to go back and replay certain portions of this video. Whoa, your body looks so much larger than your head, Lola. Is she still the same proportions? Does she still look like a normal, does she still look like the same lion, just bigger? Or is she getting kind of warped like a funhouse mirror? Notice how some of these clear containers are warping her like a funhouse mirror and others aren't. And you should be thinking, why is that happening? How is the light refracting in different ways through all of these transparent materials? Ready for our Nonagon Prism, Lola? That means yes. Okay, let's look through the Oh, Lola, you didn't tell me you had a twin, triplet, quadruplet. Oh my goodness. That is neat. And so notice this container has 9 flat sides. So notice what's happening to Lola. As the light travels from my light source through this transparent container and back at you. That is neat. But you know what's interesting? I'm noticing that there's more Lolas, but the size of Lola, are you smaller? Are you the same size? It's hard for me to tell. But then I think this portion of the jar is a completely different shape, so you're gonna look different there. Yeah, look, that's going to make you have one big wide face. But then look, you look like you have 8 legs, 10 legs. It's a good look for you, Lola. I don't know why I have lions on my mind. All right, or tigers. Is she a lion or a tiger? I don't know. You tell me. And here she is, through the flat container. That's interesting. Let's see. Is there a part that doesn't have Velcro on it? Can we do this the long way? There we go. So is she getting slightly bigger? Is she not changing size at all? You tell me. Oh, and you can see her being reflected on this side too. So there's multiple Lolas. That's pretty neat. To me, it looks like she's getting slightly bigger when you observe her through the flat side. Oh yeah, and it definitely looks like she's in a different position because her ear doesn't look like it's exactly on her head anymore. Yeah, and look, it looks like she is missing one eye and her head's getting cut in half. So there's definitely some refraction happening, but the refraction is not as dramatic as with the curved containers. So that's something that you can write. You can write that Lola still looked larger because the light was refracting, but it wasn't as dramatic as when it was traveling through the curved containers. I want you to go back in your data and see if you can make a note of with which container was the refraction the most dramatic? Through which container did Lola look the largest? Was it through the large bowl, through the small bowl, through the narrow jar, or certain parts of the narrow jar? Tell me what you noticed and then tell me why you think that happened. Okay, friends, so you can continue to add on observations if you're completing this experiment on your own, or if you just followed along with me, that's completely fine too. I want you to be super curious and have fun, so if you are able to do this at home, definitely find multiple non-luminous objects and luminous objects in your house and see what is happening when the light is traveling through all those things. Wow, I look silly. And then I will join you back to write your conclusion whenever you are ready. Remember, you have 2 entire weeks to hand this in, so if you want to take a little bit of a break and you don't have time to do it tomorrow, that is absolutely fine. I will see you soon with my thinking cap on. Okay, friends, now I am here to help guide you through your written conclusions. I hope you had a lot of fun doing the experiment along with me. I hope you're as enthusiastic about the physics of light and refraction as I am. I can't wait to see if you noticed some things that I didn't specifically mention in the video, and I can't wait to see what you discovered in your own homes. So, without further ado, you can start your conclusion by, of course, writing the word conclusion, underlining it with a colon, and then please write the word claim so I know exactly where your claim is. To write your claim, you should re-look at our science question up. How will light travel through transparent objects of different shapes? And then restate that question as a sentence. So I started mine with, when light travels through transparent objects of different shapes. And then I'm going to let you fill in the blank, thinking about what you noticed in our experiment. Did the light reflect? Did the light refract? Did the light refract the exact same way through each container, or did the light refract differently based on the shape of the container? So right now, I'm going to give you about 5 minutes or however long you need to write your claim, and you can now pause to write your claim. Okay, so your claim should be done and you should have paused the video. Now I would like you to please write the word evidence. And remember, our evidence starts by first describing what the FAIR test was and then talking about the results of the FAIR test. So I started mine by writing, I know this because we set up a FAIR test where. And then you are going to describe the FAIR test in detail. What materials did we need for our FAIR test? Remember, we did 2 FAIR tests. So right now, you are not talking about our experiment with Lola. You are instead talking about our FAIR test with the headlamp. So maybe you want to say, I know this because we set up a FAIR test where we got 6 transparent containers in all different shapes, and we shined the light from a headlamp through each of those containers and compared what the light looks like before it was going through the container to after it was going through the container. You can pause the video right now to describe what the first FAIR test was. If you finish describing the first FAIR test, you should then talk about the results of that FAIR test. Since we have 1, 2, 3, 4 transparent objects with curved sides and 1, 2 transparent objects with flat sides, this one's completely flat, and this one was a nonagonal prism with 9 flat sides, you can actually organize your writing by first talking about what happened with the curved containers and then talking about what happened with the containers that had flat edges. So if you really want to impress Ms. Scott and really want to push yourself, you can talk about each container individually, saying things like, did the light stretch out when it passed through the bowls? Did it stretch out more through one bowl than the other? Did the light barely refract when it was traveling through the flat side? Did it reflect just a little bit or not at all? And were you able to see anything super interesting and unique when it was traveling through the nonagonal prism? So now I am going to have you pause the video again, describe the results of the FAIR test by looking back at your data, describing what happened with the containers with curved edges, then describing what happened to the containers with flat edges. Okay, friends, so we're not done with our evidence yet because we did 2 FAIR tests this time. So now I used the sentence starter. Then we set up a second FAIR test where. And now we are referring to our second data chart to help us write a lot of details about what happened during our second FAIR test with Lola. So I am going to give you as much time as you need to now go through and say we set up a second fair test where, and describe that fair test that we did with Lola. Now you should have finished describing the fair test we did with Lola, and now you can describe the results of that fair test. You should look back in your data so that you remember every single detail about what happened. And again, you can structure your writing in the exact same way you did for the first fair test. So maybe you want to lump the curved containers together and talk about those first, and then lump these two containers together since they were the ones with flat edges and talk about those. And we're not talking about why that happened yet. So remember, using the word refraction and using the words luminous and really diving into why, that is for our reasoning. So I am going to give you some time now to pause the video once more and talk about what happened to Lola when she was behind each of those containers. How did she appear? And was actual Lola changing size, or did she just look like she was changing size? Did certain containers look more like funhouse mirrors where she looked a little bit silly and others just made her bigger in general? You're just talking about what happened, not why that happened. So please pause the video and complete that part. All right, so now you should have finished describing how we set up and what the results were of both of our fair tests. Now it is time for your reasoning. You should write the word reasoning, and you start your reasoning with the words, this happens because. This is where we are thinking really deeply about how the light is traveling. Remember, refraction is when light bends because it crosses the boundary between two transparent mediums. So, since these are transparent containers, the light was definitely not reflecting because they're not opaque. The light was definitely refracting because the glass is transparent, the water is transparent, and the air is transparent. So the light is going here, it was going through the jar to Lola, and then back at you. I'm going to say that one more time, and I want you to try to visualize how those photons are traveling. So all of those happy photons are traveling from my light source, then they are hitting Lola, then they are traveling back to you. So you should be writing minimum 3 sentences about why that happened, pushing yourself to use the word refract. You should definitely use the word transparent. You should prove to me that you understand what refract means. Maybe you want to define refract in your reasoning to make that super clear to me that you have mastered that concept. You also probably want to use the words luminous and non-luminous. Remember, Lola is non-luminous because she does not emit light all on her own, but the headlamp is luminous because it did emit light all on its own. Okay, friends, so right now you can actually end the video and reread all of your work after you think you are done so that you have a clear claim supported by specific evidence from both fair tests, and then reasoning that uses all of the science words I just showed you, proving to me you understand what those words mean and how to apply them. Please do not hesitate to email me with any questions or just comment on the specific assignment in Google Classroom if you have any questions about the assignment. And I hope you had a really wonderful time. Bye.